Blender is object-based. That means, for example, if I make with Shift-D and X, and copy this over, Shift-D and X, I made now 3 copies, and each copy has its unique mesh data. So for example, when we go to the property menu, I can say maybe 1, this maybe is called 2, and this is maybe called 3. Now, everything here again is just about the object center point or the container. The mesh, what you see here, is actually this when you go to the data panel. So for example, we can also call this one 1 and 2 and 3. So you see every time when I click on it, it shows a different number. And if I go into the pull down menu, you see there are multiple different mesh data blocks. So for example, I moved this one up a little bit. You see these two are individual. Maybe here I moved this one up, and here I moved this one down. Okay, so 3 objects, 3 different mesh data blocks. Let's make a new object. Let's say I use a sphere. You see now it says sphere, and actually here I could say into this object container sphere, just please show me the mesh data of mesh data 2, or maybe show me the mesh data 1 or 3, or maybe go back to sphere. So you see you can actually swap out the content of an object. And you see when, for example, I create something like this, so you see there it says number 2. This means actually that I have 2 different objects, but you see even in here it shows the mesh data block 2 is being used, so I have 2 users. Let's say I select this one and I also go to 2. Now it says 3 users. And this means actually that these 3 objects share or are linking to the same mesh data block. So where is this actually very useful? Well, these 3 are clones now. So when I go to one object and move one edge, you see the other object updates. And that's simply because the object is just a marker in 3D space where we will display this mesh data, so the polygon model. To make something a single user, I can easily click the number, and then it makes a copy of that mesh data block. So when I go to here now and change it, nothing adjusts to those because these 2 still use number 2, and this is now 2.001. So if, for example, I select an object and say make a copy, it just makes a copy including a copy of the data block. If I select an object and say make a duplicated linked, then you can see it makes a copy of the object and it links to the same mesh data block. And this is actually very useful for multiple tasks. So for example, I can have different mesh data blocks, let's say different surfaces that cut my design. Instead of having multiple copies of a design, I could simply have something like this. So I will delete everything here. Let's actually delete this one as well, and maybe make a big object, and then I will create a small plane there, and then Shift-D X, make another plane, Shift-D X, make another plane. And for example, here I will move this one up, and here maybe 2, and I move it down, and here maybe 2, but then this one I move up. Okay, so you see now I have three different ways or different surfaces that intersect this surface. So I could, for example, add a Boolean modifier to this cube and say, please trim this cube by using this mesh data. Okay, now let's say I would like to use this one. That means actually I would have to move it in, move the other one out. And you see, first I actually have to deactivate this one. There. And then I can reapply this new object. And this is a little bit cumbersome. A much easier way would simply be to keep this object. Let's say I call this one trim. And then here I have different alternative trim shapes. So for example, I call this one trim 2 and I call this one trim 3. And now I could simply select this object here and say, simply show me trim 2 data block. Let's go wire for the moment, or maybe show me trim 3. I could actually now go to here and say, no, I would like to refine maybe trim 3. So I work on my simple plane here, and you see it updates actually the mesh also on that position, because again, two objects, but they share the same mesh data. So you see the advantage of working with linked data blocks, because I don't need to move different objects in to get different cut results. I could simply select the object and then say, show me trim 2. That's okay. Yeah. One word at device. Let's say I make a copy of this one and I flatten this one down, so this way, and let's call this one trim 1. So I have three different versions. You should always need one extra object. So for example, at that position, cursor to selected, delete this one. I will just add a plane, yeah, and then make it bigger. I want to check if the object center point is all the same. It is. Okay, perfect. So this is basically my dummy object, which I call trim shape or trim object. And into this dummy object, there I will load in actually the mesh from the other objects. And you might ask yourself, why do I have to do this? The main reason is simply this, for example, now is plane 002. I have 1, 2, and 3. I can easily load now these three different stages into here. And the initial first stage I discarded because it didn't really need the flat mesh. Every time when you save and then quit Blender, it will clear everything that's not used. So if, for example, this object I link to this object mesh-wise, then this mesh actually will get lost. And I want to maintain, for example, those three different variations, which is why I need to have one proxy object from where then I can link in these three different mesh data blocks, because trim 1, 2, and 3 each is actually inside one unique object. And that's, for example, one simple example for the beauty of linked data blocks. Another one, for example, is if you would like to split something. So if I make a clone of this object, so Alt-D and escape, you see I have two objects there. And if I go to difference, you see now that I have actually two objects. And I can manipulate this one master object, the mesh, and when I leave edit mode, you see both objects are updated. So this is, for example, the way how you could easily split one object into A and B and maintain the same mesh data, because you don't want to work with two different objects. So when, for example, I modify the top object, I want not to have to modify the bottom object. So in this case here, this is just one simple adjustment in whatever part, and it will be updated to the other part. Now the only thing that's a little bit annoying when doing something like this is when we hide this, we can't really see where these objects are split. And we also do this split object a lot when we want to simulate different materials, let's say something that's rubber overmolded or so. So when we go to, for example, cube, and let's say this is cube 2, we would like to give it a material, and let's say plastic, and I make this plastic red. And you see the other object is red as well. Now if I click this one here and say no, don't be red or plastic, you see the other top object gets the material change as well. So this is a little bit annoying. So what's happening here? So we added the material plastic, and this material is currently, as you can see, linked to the data, and the data is actually this mesh. And you see both objects share the same mesh, and because we say this mesh is red, each object shows you a red mesh. So what we have to change in that case is say, don't apply this mesh to the data, but to the object. So for example, for the top one, I click object, then I can click new, and for example, make it blue. And let's say this is rubber. And there you can see now this way we have two different objects, but they share actually the same mesh, and they're split by the same Boolean command, and not command, Boolean surface. And then now this way I can not only interactively quickly split one object into two while maintaining the same geometry for the object, but I can also then easily colorize the different parts, which will be very useful for presentation or visualization purpose. And if I select this object, I can go back to data, then again it will be red. If I go to object, it will be this color. What happens if I do object here? See, I can even give this a complete unique color, so the color actually from the data block is completely gone. One last thing I would like to show, if this one I hide now, and let's say this object here we make new, and then say please have let's say magenta, and let's say we call this one Boolean there. Click this object plus, and then say Boolean. You see actually that now wherever this object cuts actually this object, the mesh is colorized. So what's happening here is whatever is magenta here right now, that geometry comes from actually this mesh. And this mesh has this color, so this Boolean material, and thus this object maintains its normal green material. And then however this, for example, is designed, it will then recreate the polygons for this cut section and then apply this Boolean material. And you see actually that if I remove this one and maybe give this a different material, this is not getting blue. So it needs to be the same material that the cut object has, so that you can see this material where the Boolean modifier, this one, generates this polygon mesh, and then it uses this color and applies it to there. So if, for example, I select this object and the material and change it, you see how it updates on the left side. So this is actually pretty awesome.